Namaste and welcome to this introduction class on digital communication. At the onset, let's review what we are going to learn in this course. We will start off with the definition of communication system, and we will discuss why digital communication is used. That is, when we have so many analog communication techniques available, why are we moving to digital communication? We will then look at the broad classification of the digital communication techniques, followed by the sampling theorem and quantization. We will see the baseband data transmission and bandpass data transmission. The baseband data transmission will include pulse code modulation, differential pulse code modulation, and delta modulation, while the bandpass data transmission will include amplitude shift keying, phase shift keying, differential phase shift keying, and M-array signaling. We will conclude with a detailed discussion on constellation diagrams. So, what is a communication system? It corresponds to the entire setup, hardware and software, using which information is transmitted from one place to another, from one node to another node. The best example is the communication between you and me, which is happening over this World Wide Web. At my side, I am just speaking on a mic. My voice, which is an analog domain, is converted to the digital domain by this setup, that is the mic. That information is transmitted to you via the internet. And at your side, again the reconversion is taking place, that is from digital domain to analog domain, and that is done by your speaker or your headphone. And you can listen what I am saying. Means the information has transmitted from me to you through this entire setup of which includes different hardwares, different softwares. Why digital communication? That is the first question we need to answer. We have so many analog modulation techniques available with us. So why we are moving to digital communication? The first and foremost is the less effect of noise. Digital communication systems offers more resistance to noise. We are well familiar with the fact that noise is the most problematic factor for any communication system, and digital communication systems can provide us better solutions towards eliminating this problem of noise. Secondly, using some error correcting codes, we can increase the possibility of correcting the errors which happens during transmission. In other words, the possibility of errors can be reduced. In digital communications, we have regenerative repeaters. We do not have any such thing in analog communication. Lastly, digital data can be stored efficiently as compared to analog data. Moving towards the classification of digital communications, we have two broad categories: the baseband data transmission and the bandpass data transmission. The baseband data transmission itself is divided into two parts: the pulse analog and the pulse digital. The pulse analog contains pulse amplitude modulation, pulse width modulation, pulse position modulation. While the pulse digital which we are going to see in this course has pulse code modulation, differential pulse code modulation, delta modulation, adaptive delta modulation. On the other side, in band pass data transmission, we have binary signaling and M array signaling. For example, QPSK, 8PSK, etc. The primary difference between these two categories is the frequency which is used for transmission. In the baseband data transmission, we directly transmit the rectangular pulses over a cable. That cable may be anything, a fiber optic cable or coaxial cable. Whatever binary bits we have, we directly transmit through those cables. While in the band pass data transmission, the binary bits are mounted on a high frequency carrier, and then that carrier is sent through space. In other words, if we want to go for wireless transmission, we have to opt for this band pass data transmission. It is not possible to transmit these rectangular pulses directly into space. In band pass transmission, a high frequency carrier is used to transmit the binary data into free space.